These are the Lesson 11.1 notes on mathematical patterns. Today we're going to look at things called recursive and explicit formulas, how to write formulas for these things, and how to find terms of these types of formulas. We're going to start with something called a recursive formula. And if you look at the word recursive, you see this prefix re on here. If you think of words like reuse, recycle, retake, the word recursive has to do with something that's occurring over and over again, repeating some type of pattern that we're reusing here. In a recursive formula, we first name the first term and the pattern that takes you from the first term to each of the next terms. Let's look at this pattern of numbers, 60, 50, 40, 30, 20, 10. I think you know what the pattern would look like if we kept this going. And in a recursive formula, we need to know the first term. In this sequence of numbers, the first term is 60. And we also want to address what the pattern is. And the pattern here is that the numbers are getting 10 smaller each time. So to get from one number to the next, what we're doing is we're subtracting 10 each time. We say in this pattern of numbers that a sub 1 is equal to 60. So that's the first term. We pronounce it a sub 1. A sub 2, the second term, is 50. A sub 3, the third term, is 40. A sub 4 is 30, etc. So the recursive formula for this sequence of numbers is written this way. A sub 1 equals 60. That's our first term. And then a sub n equals a sub n minus 1 minus 10. When you write recursive formulas, we always state the first term as a sub 1, whatever it is. So a sub 1 is 60. That's our first term. A sub n stands for any term other than the first term. The word any starts with the letters an. So think of a sub n as being any term. So to find any term, a sub n, we take the previous term, which is written as a sub n minus 1. So a sub n stands for any term. If we subtract 1 from the subscript, it means the term before it, the previous term. So this line right here means a sub n, any term, equals previous term minus 10. So let's try to write recursive formulas for these other two patterns. Let's start with this sequence of numbers that's going up 5, 10, 15, 20, 25, 30. We know the first term is 5, and the pattern is we're adding 5 each time. So when you write your formula, it needs to consist of two things. I usually start with this left side set bracket. We always start with the first term, which we write as a sub 1. So here, a sub 1, the first term, is equal to 5. And then to find any other term, a sub n kind of means any, we take the previous term and we add 5 to it. So to get from 25 to 30, we add 5 to 25. To get to the next term, I'd go back to my previous term, 30, and add 5 to it to get 35. So we take each previous term and add 5 to it. And this is what your formula looks like. What I'd like you to do is pause the video and see if you can come up with the first term, pattern, and formula for this sequence of numbers. We'll pause the video and see what you get in just a moment. So it's pretty obvious our first term is 60. The pattern here is each time we're dividing the previous term by 2 to get to the next term. You could also consider this as being multiplying by 0.5 or 1/2 as well. If we consider the division approach, what you would write with your set brackets, a sub 1, the first term, is equal to 60, and then any other term, a sub n, is equal to the previous term divided by 2, or times 0.5. So for example, to get to the next term, I would take 7.5 and divide it by 2. We're next going to write a different type of formula called an explicit formula for number patterns. In an explicit formula, we determine what relationship the number has with the term number itself. Now, if we go back to our sequence 5, 10, 15, 20, 25, we know what the next number is. But what if we wanted to skip ahead to the 10th number, for example? First of all, let's look at a relationship not of increasing by 5s going horizontally, but what's the relationship vertically in this column? How can you get from the number 1 to the number 5, from 2 to 10, from 3 to 15, 4 to 20, and 5 to 25? What relationship does each one of these term numbers have with the term itself below it? Well, I think if you notice, if you multiply each term number by 5, you get what the actual term is. The first term is 1 times 5. The second term is 2 times 5. The fifth term is 5 times 5. So that's our relationship, is we take the term number times 5. So what number should go under the 10? Well, 10 times 5, and that's 50. What we say is that the explicit formula for this sequence of numbers is to find any term, a sub n, we take 5 times the term number. So in this formula, a sub n still stands for any term, including the first term. So we don't have to know what the first term is because this formula works for the first term. N is the term number. So this line right here means to find any term, it's equal to 5 times the term number. Now let's try to write some explicit formulas for 2 more patterns, and it may help to write the term number above each term. For example, for this first sequence of numbers, we go 11, 12, 13, 14, 15, 16. Obviously, the recursive pattern is we're adding 1 to each term, but now we're writing an explicit formula. I'm going to write the term number, we're going to call this n, above each term. So I'm going to write 1 above the 11, that's the first term. The second term is 12, the third term is 13, so on and so forth. The numbers underneath the n's are what I'm going to consider to be the a sub n's. Now, what's the recursive formula? The recursive formula is basically take the first term, 11, and then add 1 to get to the next term, or take the previous term plus 1. For the explicit formula, what we're going to do is we're going to talk about what a sub n equals in relationship to what's right above it. How is each number on the bottom related to the number on the top? How can you get from the number 1 to 11, 2 to 12, 3 to 13? What's the same pattern that exists between each term and the number right above it? Well, if you add 10 to each term number, you get what the term actually is. So in this situation, what we do is to find any term, a sub n is any term, we take the term number, which is n, and we add 10 to it. So if you wanted to find the 20th term, you could just take this number, 20, and add 10 to it. Let's see if you can figure out an explicit formula for this pattern of numbers. So I'm going to have you pause the video again and see if you can come up with the explicit formula that generates this sequence. Pause the video and we'll see what you get in just a moment. So I've rewritten the term numbers above each term, 1, 2, 3, and 4, and I've labeled this n and a sub n. Now you'll notice each of these terms is a fraction. So to find any term, again, a sub n is for any term. To find any term, it's going to be 1 over something. So really what I've got to figure out is how the bottom number of the denominator relates to the term number. So if to get from 1 to 10, or 2 to 11, or 3 to 12, or 4 to 13, what we have to do is we have to add 9. So we're taking the term number and we're adding 9 to it. That gives us our denominator. So the explicit formula is a sub n equals 1 over n plus 9. Does it work? Well, if you plug in 4 for n into our little problem here, you would get a sub 4, the fourth term, equals 1 over 4 plus 9 is 13, which is your denominator. Now, that's an example of how to find a term, and what we're going to do in our last few examples is find terms using recursive and explicit formulas. To revisit recursive formulas, what you'll be given is the first term in the formula, then you're going to follow the pattern described in the second line. For example, if the problem says a sub 1 equals 4, hey, that's your first term. So we're going to put a 4 right there. This is a sub 1. Now our goal is to find a sub 2, a sub 3, a sub 4, and a sub 5. This term says to find any other term, take the previous term and add 6 to it. So to find the second term, take the previous term, which is 4, and add 6 to it. To find the third term, take the previous term and add 6 to it. To find the fourth term, take the previous term, add 6 to it. And to find the fifth term, go back to the previous term, which is the fourth term, add 6 to it, and you get 28. It also works if you substitute numbers into the formula. For example, if you wanted to find the fifth term, you could replace each n in the equation with a 5. So for example, to find the fifth term, a sub 5, you take a sub 5 minus 1 plus 6. Well, we know a sub 5 minus 1 is a sub 4 plus 6. And a sub 4 was equal to 22. And that's the whole idea of taking a previous term and adding something to it. What I'd like you to do is I'd like you to pause the video, see if you can find the first 5 terms for each of these sequences, and we'll see what you get in just a minute. Pause the video, and we'll see you in a minute. So in our second example, we know our first term is 12. That's going to go here. Then what we do is we're going to take 2 times the previous term and add 3. So for our next term, we're going to take 2 times 12, which is 24, plus 3. To find the next term, we take 2 times the previous term, 27, that's 54, plus 3 is 57. For our next term, we double this number, that would give you 114, and add 3. And then we're going to take, for the last term, the previous term, 117, double it, that's 234, plus 3 is 237. Now the last example is a little bit trickier because while we do have our first term, then we have this statement here which involves a sub n minus 1s and n's. A reminder, a sub n is any term, a sub n minus 1 is the previous term, and n is the term number. So for this example, if you're looking for any other term, like let's say the second term, to find the second term, you take the previous term, which is 1, and then we're going to add the term number, which is this number, the subscript, and you get 3. Now, if that's a little confusing, let's do a couple more examples so you understand. To find the third term, we take the previous term. Now, the previous term, so here we are in the third term. To find the previous term, which is, to find a sub 3, we're going to take the previous term. So here we are in the third term. The previous term was 3. And we're going to add the term number. This is the third term, so we're going to add 3 to that. And you get 6. To find the fourth term, we take the previous term. Now here's our fourth term. The previous term is 6. And then we're going to add the term number. This is the fourth term. And you get 10. And for the last number, the fifth term, we take the previous term, which was 10, and we add the term number. This is the fifth term. And you get 15. So in each situation, we're going back to a previous term, but then we're adding a term number. That's a little tricky. For explicit formulas, these are easier because you simply substitute 1 into the equation for x to find the first term, or n, and then you substitute 2 into the equation to find the second term, and so on and so forth. To find any particular term, substitute the term number into the equation for x, or in our cases, n. For example, for a sub n equals n plus 1, to find the first term, you're just going to do the term number plus 1. 1 plus 1 is 2. To find the second term, you're going to plug in 2 for n. 2 plus 1 is 3. To find the third term, you're going to plug in 3 for n. 3 plus 1 is 4. And so on and so forth. The fourth term is 4 plus 1. The fifth term is 5 plus 1. What I'd like you to do is pause the video, see if you can find the first 5 terms for these next sequences, and we'll see if your answers are correct in just a moment. And for our last set of answers for the second sequence, we get the sequence 0, 3, 8, 15, and 24 by plugging in 1, 2, 3, 4, and 5 for n. For our last sequence of numbers, when you plug in 1, 2, 3, 4, and 5, you actually get these fractions. I'm going to reduce things like 0 over 2 to 0, 2/4 to 1/2, and 4/6 to 2/3. And when we go over answers like this in class, that's what I expect you to do as well. And now you know how to work with recursive and explicit formulas for sequences.